Hello everyone, my name is Matias, I'm from UPC and I will be presenting my latest work, Optimum MPPT strategy for low power pendulum-type wave energy converters. One of the biggest challenges in Lagrangian drifters is autonomy. I've been recently working in the design and develop of kinetic energy harvester systems for drifter applications that turns the oscillation of the waves into electricity. In these systems, a power management unit with a maximum power per tracking technique is crucial. My device is a pendulum-type mechanism that turns this oscillation into rotation and is based on a DC electrical generator. It can be modeled by the following Thevenin cabling with its MPP at the half of the open circuit voltage. Different approaches can be used to perform the MPPT, as perturb and observe, which is complex and power consuming, or the fractional open circuit voltage technique, which is simpler and has inherent losses. In this work, the kinetic energy harvester systems that includes the kinetic device, the power management unit, and the energy storage element was placed in a linear shaker. This was then controlled by a function generator, a whole measurement system that provided the acceleration and the power data was also placed. Three MPPT techniques were used. First, one based on the fractional open circuit voltage using the analog device power management unit, which opens the circuit every 16 seconds to sample the voltage and fix the half of this open circuit voltage. And as these 16 seconds may be slow for the current kinetic energy harvester dynamics at the sea, a second technique was used. We used another function generator synchronized with the shaker movement that provides a simulated UV MPPT signal, and we tuned this signal to match with the half of the open circuit voltage. Finally, a third technique providing a fixed reference as UV MPP. Three tests were performed in the laboratory using these three techniques with a linear shaker, previously characterized. For the fractional open circuit voltage second technique, we can see here how the signal generated match with the current half of the voltage open circuit of the generator. In the view of the results, we can see that up to 20% of the energy extraction can be improved with this simulated fast fractional open circuit voltage technique. The main achievements of this work are the kinetic energy harvester design prototype, the development of the measuring system that provides inertial data and power, the linear shaker characterization, also the adaptation of three MPPT techniques, the dynamic sensing mode, the no sensing mode with the fixed and the simulated signal. And we can say that the energy extraction can be improved up to 20% using this technique. Thank you for listening. And if you have any doubt, don't hesitate to contact me. Bye.